So I'll just read this. It might not make sense right now, but as we get to the first few slides, it'll start to make some sense. But today we're going to learn a new formula called the change of base formula. It helps you to evaluate logarithms that you wouldn't be able to evaluate using the methods we've learned so far. Okay, so there's sometimes where there's going to be logarithms where we can't just do the strategies we've learned to find the answer. So we have this little formula that we're going to use to figure it out. Now, for this one, this is one that we should be able to do mentally. Does anybody know what this answer would be? Or it's 2, right? Good. The reason it's 2 is because 4 to the second power equals 16. So the answer is 2. Right? So that's one that we could do mentally. But if I gave you this, we would have a problem because it can't equal 1 because 4 to the first power is not 10. It's not big enough, right? 4 to the power is only 4. It can't be 2 because we already know that 4 to the second power is 16, so it can't be 2 either. So 1 is too small, 2 is too big. That means it must be something between 1 and 2, okay? Which means it's like a decimally kind of answer. And we don't really have any strategies for getting those, but somebody came up with a formula that we're going to use called the change of base formula. And the reason that's helpful is because of this. On our calculators, you guys notice that there's 2 buttons on here. There's 2 logs on the calculator. One is called log, the other one's ln. So the calculator can do any log that we want to, if so long as log or ln. Okay, but if it's a different log like this one here, 4, the calculators, some calculators are not able to do those because they only have log base 10 and ln on there. So what we're going to do is we're going to learn a formula that will change this base from being a 4 to being a 10. That way we can use the calculator to get the answer. All right. So that's what we're doing today. That's a change of base. So it's a formula that helps you do logs that you can't just do mentally using the calculator. So here's the change of base formula. Log base b of a is the same thing as log base 10. So I don't need to write the 10, but I want to use base 10 because that's what's on my calculator. Log base 10 of a divided by log base 10 of b. So whatever number's here goes on the top, and whatever your original base is, that's going to go on the bottom, and both of those are being logged with a base of 10, so my calculator can do that. Now technically we could also do ln instead of log base 10 because it would give you the same answer, just changing it to a different base, but it would still give you the same answer. So I want to show you guys that this thing works. So for instance, on the last slide we had this, log base 4 of 10, was it? Okay. So, well, I can't do that mentally. My calculator doesn't have a base 4 on it. So I'm going to do log base 10 on the top and on the bottom. For the top, the 10 is going to go up there. And for the bottom, the 4 is going to go there. Now, we could type this in if you guys want to do it together. For now, why don't we just show you the answer, and then we will we'll practice typing in a minute. But yeah, my calculator is dead. All right, so log 10 divided by log 4. Remember how I said the answer? 1 was too small, 2 was too big, so it had to be somewhere in between. Well, here's the answer. I got 1.66, about 1. Okay, so what that means is that log base 4 of 10 is 1.661. In other words, 4 to the 1.661 power is approximately 10. I'm going to say approximately because I had to round, but there it is. So that's the change of base formula. So when you have a logarithm that you can't do mentally, we're going to change the base into a base 10 using this formula, and then use our calculator to get the answer. let's go ahead and do our first. All right, so let's go ahead and take a look at example 1. Now, if you ever see one that you could do mentally and you just know the answer, go for it. But 5 and 20, there's no answer to that. 5 to the second is too big. That's 25. 5 to the first is too small. So this is another one where I have to change of base. So let's do change of base. Let's write it out first. We do log base 10 on the top. We do log base 10 on the bottom. Big number here goes on the top. The original base goes on the bottom. And now we're going to type this into our calculator. So let me walk you guys through how to do this. On your calculator, it's going to look like this. You're going to push the log button. You're going to type 20. You're going to close your parentheses. You're going to push the division button. Then you're going to push log again. Enter 5, close your parentheses, and then you're going to push equal. So make sure you close those parentheses around the 20 and also around the 5. I think those are dead now. Yeah, grab from this side over here. All right, so go ahead and do log 20, close your parentheses, divided by log 5, close your parentheses, equals. And let's see what you guys are getting out there. So, Steve, what did you get for that, sir? 1.861. Great. There you go. 1.861. Now, you don't have to write this, but that means that 5 to that power should be approximately equal to 20, right? If you guys want to try that on your calculator, try it. Do 5 to the 1.86 power. It should be really close to 20. Okay? But just to be clear, this is the answer. But if you want to check your work, you could do that if you want to. Okay? All right, let's go ahead and take a look at the second one here. All right, so once again, I'm looking at this. 6 to the third power is something like 200 and I don't know, 16. I can't do it in my head. So that's too big. And 6 to the second power is 36. That's not big enough. So it's got to be somewhere between 2 and 3. So I can't do it mentally. So we're going to do base, change of base, log base 10 on the top, log base 10 on the bottom. And Damiani, what number goes on top? The 100 or the 6? Yeah. The 6 is what goes in the bottom. So go ahead and type that in, and I'll ask you what you got. What did you get, Cynthia? 1.5700. I think it should be 2 point something. I'm wondering, did you close your 100 in the parentheses? Make sure you close the parentheses there. Go ahead, Steve.
2.570.
Okay, that sounds reasonably. Now the reason that sounds reasonable to me is, remember I said that 6 to the third is too big, but 6 to the second is too small. So it had to be between 2 and 3. And there it is. So let me ask Lily, what would this be if I wanted to check my answer like I did here with the other one? Is equal to? Yeah. So it should be approximately equal to 100. Once again, you don't have to do this. I'm just showing you what our answer means. This is the answer that we're looking for. All right. So there it is. So let's go ahead and move on to number 3 here. Crystal, what's the base on this log here? Yes. Now, that's what's on our calculator. So I don't need to do change of base for this one. So just enter it on your calculator just the way it looks. Do log 10 and then enter. I'm sorry, log 60, my bad. Log 60 and then enter. We should be getting 1.778. Same thing here for this guy. ln, well, that's on my calculator, so there's no need to do change of base here. We're just going to do ln and 3. And that would be 1.099. Okay, so only you don't need to just change the base all the time, right? Only if necessary. So only if you have a number that's not 10 here and you can't do it mentally. Okay. So that's that. I'll let you guys try these two here. There's our answers. By the way, this is one that we might have been able to do mentally. You could ask yourself 4 to what power equals 2. And then we could change the 4 into 2 squared. Cross those off. And you could solve for x. That's a possibility. This one you would not be able to do that. But once again, the change of base works regardless of what strategy you use. So there you guys go. So that's change of base. It's basically figuring out what does a log equal when you can't do it using the strategies we've already learned. So why are we learning this? Well, generally in math, you need to plug numbers into functions to get answers. So that's helpful. But also, we're going to use it for graphing later on to get some points to plot dots with. So that's what we'll be using it for. So we're going to do a little bit more of this evaluating thing, but we're going to make the equations a little bit more involved. So let's go ahead and begin here with number 1. So I give you a function here, and I ask you guys to find f of 10. And what that means is we're going to plug 10 in for x. So let's do that. So we have f of 10 is equal to 5 log base 2, 3 times 10 plus 4 minus 8. So we'll plug our number in first. All right, now we're going to simplify inside the parentheses. So in here, what does 3 times 10 plus 4 make?
34.
Yep, 34. So that's simplifying inside the parentheses. The next thing we're going to do is we're going to take care of this log here. Okay? So now we're going to do the change of base formula. So the 5 is going to stay there. And this whole thing here, that's going to become log 34 goes on top, 2 goes on bottom. I'll put it in parentheses just so it's a little bit easier to see here. So all I did was I'm going to take care of this now. Log base 2 of 34. We just do it like we did before. You do log 34 over log 2. And now we're going to let our calculator do the work for us. So go ahead and calculate that and see what you get. All right, someone got an answer they want to share with us? What did you get, Bill?
5.087.
5.087. Yep, that sounds good. Okay, so next thing we're going to multiply this stuff here together. So let's do that. On your calculator, you can just push times 5 after you have your answer there. So 5.807 times 5. Getting 25.435. So that's multiply, right? And then finally subtract. Or in this case, it won't always be subtract, it could be add. But so just push minus 8 and 17.435. And there's our answer there. So like I said, we're going to use this for graphing a little bit later. This is like the x value that we plug in. This is like the y value that we get out as an answer. So that's like a point on a graph, which we'll talk about more next time. So let's review. So step 1 is to plug in your value for x. Simplify what's inside the parentheses after that. Use the change of base to rewrite it. Use your calculator to get that answer. Multiply, add or subtract. You should have your answer. Let's go ahead and take a look at number 2 here. All right. So Cal, what am I going to do first here on number 1, or number 2, I mean? Yep. Plug in 12. DeAndre, what's next?
To simplify.
Particularly what?
Parentheses.
Simplify inside the parentheses. So if we do that, what would that come out to be? 7. I left off my base there. You know what that would be, DeAndre?
23.
Nice. Go. Go ahead and do the third step. I'll ask somebody what to do in just a second, but I'll give you a head start on it. The change of base next. And that's log 23 over log 7. All right. Oh, and what's next? Use the calculator. So let's go ahead and do that. I'll ask you guys what you got there. And Michelle, what did you get for your calculator outcome there? Number 2. Like that? seems reasonable. All right. Amethyst, what's next? Cool. Let's do that. Multiply. I get negative 4.833. And then Brittany, what's next? Just add. Last time we subtracted, but this time it's adding. So, but it is a negative. So we have a negative 4. Now when you do negative, remember negative's on the bottom of your calculator. This is a minus. Don't get those mixed up. So negative 4.833 plus 5. Should be getting 0.167. Once again, this is like a point on the graph. The x value is 12. The y value is 0.167. We'll be using that to graph. I'm going to do number 3. I'm going to go through it a little bit quicker, though, because I think we have the point here. But I wanted to show you something about number 3. I'll leave that up there. All right, so first of all, for number 3, we're going to plug stuff in, right? Plugging in 3. We're going to simplify inside of the parentheses. You guys see what's different about this one? There's no number on the bottom of the log, which means that it's what base? So do I need to use change of base? No, we could just do log 5. So, matter of fact, you could probably just type this whole thing into your calculator now. Just do 4 and then log parentheses 5 parentheses minus 10. So you don't have to do change of base here. No change of base needed. Why? Because it's base 10, and that's what's on our calculator already, so there's no need to change it. And like I said, you could, instead of doing it like doing the log first and then multiplying 4 and then minus 10, you could just type that whole thing in your calculator and get an answer. Technically, we could do that up here also, by the way. It's just that it's a little bit, you have to type it in just right with all the parentheses in the right spot, so I just choose to do it in pieces. But here we go. So 4 log 5 minus 10, I get negative 7.204. Okay? So if you ever have just a log here, base 10, or an ln, there's no need to do change of base. Just work it out the way they give it to you. If it's something else, then go ahead and do change of base. All right. I'm going to stop with the examples, let you guys practice that, and I think that'll be it for the day. So do these 2 problems here, and we'll have someone present them on some whiteboards, and when you're done with that, that'll be it for the day. Okay, so you got the answers up here. If you want to check your work, you're welcome to. Let me know if you guys have any questions about those.